Hello everyone, my name is Hemu and today's we are here for our first class of PaloAlto Firewall. Before starting the session, let me just tell you guys, see, if you will see my screen, this is the contact number, right, which belongs to me. So you can basically save this particular contact number somewhere in your phone and you can basically, I have a WhatsApp as well on the same number. So you can able to basically ping me on WhatsApp as well for any type of doubts, any type of issues. Avoid pinging me late nights. Okay. This is my email ID. So you can also text me over the email. This is my LinkedIn profile. And guys, here you will also get the link of our video portal, right? So Charu ma'am will share all that detail and she will help you with that part. Okay. Now, so as I mentioned, I used to divide your classes in day by day, like day one, then your generally this day one and day two I used to cover this content only, right? Then we have a day three, right? Then we have a day four, like that your classes will go moving forward. Okay, and I will share this text file as well with everyone, so you can refer that particular text file as well. Okay, now let me just start the today's session. So guys, if you will see in today's session what we are going to discuss, I will start your classes with what is firewall. So first we will try to understand what is firewall, then we will see what is stateful inspection. So to understand this stateful inspection, you also needs to understand what is stateless devices, how stateless devices functions. Okay, then we will go through with the Palo Alto Firewall history. Palo Alto Firewall product portfolio means what type of devices, what type of solutions offered by the Palo Alto networks. Then we will see what is the operating system of Palo Alto, what is the Palo Alto hardware series, VM series, right? Then what is the SP3? And guys, see, I am telling you, if you will know this SP3, you can able to crack the Palo Alto interview, because in every interview, if they will basically, if you will tell you have experience with Palo Alto, they will ask this question, what is SP3? And if you know the SP3 properly, you can basically explain this particular topic around 30 minutes. Okay. Then the second most important topic is packet flow. Then the initial access. So these are the particular topic which I am going to cover in this particular today's class. And guys, always remember, see, I used to provide these type of links actually. Okay, so what you have to do, you have to basically go to into these KV articles and you have to read these articles properly. So that is the reason I have added them here in this particular text file. So now let me start with what is firewall. Okay, so guys, if I will tell you the definition of firewall, maybe most of you already aware about what is firewall, what is the use of this device called firewall, but I'm just starting from the basics. So let me just cover that as well, right? So if you will see, a firewall is a software or hardware based network security system. Means the device called firewall, it may be a software device or it may be a hardware device. Means it may be your physical appliance. Software means, see guys, in your laptop, you have heard the name of, in Windows, we have a Windows Defender, right? In Linux, we have a IP tables, right? This particular device is also an example of software based firewalls, right? Sometimes, see, in software example of this software based firewall, let me just tell you, see, when you used to install any type of virtual firewall, VM series firewalls, like let's suppose you are running your firewall, or let's take an example, Palo Alto Firewall, right? In AWS environment. In AWS environment, we are going to run this firewall as a VM device, right? So this particular thing also comes under the software only. So generally what we have a two type of firewalls, software based firewall and hardware based firewall. The major difference between software based or the hardware based, see, hardware based firewall have a high throughput, means they can able to process the data in GBs, maybe your hardware based firewall or the physical appliance can able to process the data around 20 Gbps per second, or maybe 10 Mbps per second, right? But your virtual devices, they have a very less throughput. And apart from that difference, see, this physical appliance, whatever the hardware component we are having in this particular device called firewall, in physical appliance, that hardware is specially designed for doing the firewall functionalities. Okay, because that hardware is tested. But when you will install any software based device or any virtual firewall, that time what we are using the hardware of any other platforms, right? Maybe we are using the hardware of any of the server, like we are using HP server or Dell server, right? And on top of that HP or Dell server, we used to install the virtualization platform like VMware, right? VirtualBox. And on top of that particular VirtualBox or that particular hypervisor, we used to run the virtual devices. Okay, now, so this particular device called firewall, what it used to do, it used to controls the incoming and outgoing network traffic. So guys, incoming, do you know what is incoming traffic? What is incoming traffic, guys? Let's take an example. See, this is my PC and I'm in my office LAN network, and let's suppose this is the Facebook server. Now from this PC I'm accessing this Facebook server. Now what type of traffic this PC has initiated? What is the this is the packet number 1. What type of traffic it is with the with regards of this firewall? This is a outgoing traffic, means because this traffic is leaving your organization boundary. It is going out from your organization. So it is known as outgoing traffic. When this particular Facebook will send the reply, this reply is known as incoming traffic. And what firewall used to do? Firewall used to control incoming and outgoing network traffic by analyzing the data packets. Now here they have introduced a term called data packets, and determining whether they should be allowed through or not based on the rule set. Rule set means the configured access control list or the configured policies. Now let me just design one diagram and let's try to understand each and everything here. What I can do, let me just minimize the size. Guys, just tell me, are you able to see the size here for this firewall properly? Okay. So let's take an example. Let's say we have a PC here. Let's say this is PC1. This PC have a connectivity. I am denoting the firewall directly here, but in your organization, maybe this PC have a connectivity with the wireless AP or maybe with the switch, right? Then the switch have a connectivity with the router. Then that router may have a connectivity with the firewall, right? But I'm going directly with the firewall connectivity here. Then here we have an internet service provider, ISP, and here we have one of the server. Let this server, guys, what is the port number of HTTPS? What is the port number for HTTPS? 443, right? So let's suppose this server running running the web service on TCP port 443. Okay, and this server have the public IP address which is 151.7.100. This is the public IP address it is having. This PC is my local LAN. It has a private IP address. So let's suppose 10.1.1.10 is the private IP address which we have on this particular PC. This firewall have an interface Ethernet 1x1 connecting with the internet service provider or your internet router, and we have a Ethernet 1x2 connecting with your LAN network. So this part is your inside network, and this part is your outside network. Okay, now, so this is the basic diagram I am having now. Now, guys, tell me one thing. See, on this particular server, I am running the web services, right? So if I'm running the web services, then just tell me one thing. Now, on this particular PC, I have opened the web browser, and what I have on that web browser, I have just typed the IP address of that particular server. Now, what happened, guys? What are the activity happen on this particular PC when I have typed the IP address of that server? What is the first packet this particular PC will initiate? Synchron, it will not do the DNS because I'm just typing the IP address directly, right? So it will basically start with the TCP three-way handshake. And what it will send, the very first packet which is sent by this device is a TCP SYN packet. Right? Then this SYN packet received by the firewall. Firewall process this SYN and it will basically forward towards the web server. Now this particular web server, he will reply. What is the reply packet we will get? TCP SYN plus ECK. And after that, ECK packet. And once this particular, these three packets, they will exchange between this PC and server, what will happen? Now, between this PC and this particular server, that TCP connection will be in a established state. Means now connection is in established state. Now, once this TCP three-way handshake will complete, now they will start with the SSL handshake. I'm not touching anything with regards to SSL handshake. We will do lots of things before jumping into that topic. Okay, just I will stick my discussion till this TCP send packet. Now, guys, in this TCP send request, if I will write down the packet, what is the source IP address? Source IP address is 10.1.1.10. Destination IP address is 150.1.7.100. Then we have a source port. Then we have a destination port. Destination port is 443. Guys, what is the source port this particular PC will take? So it generally took the random port number starting from 1024 till 65535 or the ephemeral ports. Mathly, you are right. Okay. So like port number which is starting from 1024 till 65535, they are the ephemeral ports, right? Let's take an example. It has taken 3050. Okay. Now, so guys, now see, now this PC, when he has forwarded this request towards this particular firewall, so what this firewall will do, this firewall basically start processing this particular request. So generally, see, when is this firewall do the process of this request, it will process into some stages. Okay, and these stages I will discuss in some time. So what he will see, now this send request when received by the firewall, right? So this particular request is going out. So this particular request becomes your outgoing traffic, right? And we are getting as a reply which is TCP SYN plus X. So that become the incoming request. So what firewall will do? It will basically control this particular traffic, or it will basically do the inspection. Now, guys, what do you mean by the control? Control means this firewall may allow this traffic or he may drop this particular traffic, right? This is the controlling. Now, see, guys, let's take an example of gated societies. See, let's suppose you are like most of us is living in these societies, right? So guys, what is the job of this security guard in the gated society? Generally, when any random person used to go inside your society, what they used to do? They used to basically do the checklist. They may check his Aadhaar card, right? They may also call you if it is an authentic person or not. Means now how this particular device will do the same thing, because see, security guard is also doing the same thing. Either he will allow, either he will drop, he will deny, right? And your firewall will also do the same thing. Either he will allow or either he will deny, right? So what it will do, see, this device will basically allow or deny the traffic on the basis of layer 3 information and layer 4 information. Means source IP, destination IP, source port, destination port, and the protocol, which is your layer 3 protocol. Right? Because see, on this firewall, we will allow this traffic or we will deny this traffic. What? We will configure the rules or the access control rules or the security policies. Now on these rules or ACLs or security policies, what we have? Your security policies, they are the combination of your source IP, destination IP, source port, destination port, your zone details, and the action, allow, deny, whatever we want, right? Means this particular device, it can allow the traffic or it can deny the traffic on the basis of layer 3 information or the layer 4 information. I'm just going with the general terms right now. I am not introducing anything at the layer 7. Okay, layer 7 we will discuss later, don't worry. Now, I hope you will understood what is the main job of this particular device called firewall and how this firewall basically control the traffic. It controls the traffic on the basis of your IPs and port numbers, means on the basis of layer 3 and layer 4 device. Means your firewall majorly works between layer 2, layer 3, layer 4 and layer 7. We can also use the same firewall as a layer 2 switch, and we will discuss that deployment. But let me tell you guys, for this layer 2 activities, we have a dedicated device called switch. So your firewall is a layer 3 device because it works at layer 3 majorly. Okay. Now, let's back here. So what firewall used to do, or what is, so this particular device, what it will do, it will allow or deny your incoming and outgoing traffic by analyzing the data packets. Means what it will analyze, it will basically check your layer 3 information or layer 4 information from the packet. At layer 3, what we have, a source IP, we have a destination IP, and we have a layer 3 protocol number. And at layer 4, we have a source port and we have a destination port. Guys, what is the layer 3 protocol number for TCP? 6. What is the layer 3 protocol number for UDP? 17. What is the layer 3 protocol number for GRE? What is the layer 3 protocol number for ICMP? GRE 47, I hope, or what is? I am not remember exactly. GRE. Then what is the layer 3 protocol number for ESP? 50. GR is 47, ESP is 50, right? So guys, these are the layer 3 protocol numbers. Means how my firewall or how the transport layer gets to know what is the protocol number, what is the basically, what is the like, what is the media they have to use for transferring the data, right? At transport layer. So your layer 3, your IP header, it has the information of this layer 3 protocol number, just remember. So these are the right now, this is the information which is utilized by the firewall for allowing or denying the traffic, just remember. Okay. And this particular, whatever this ESP, these are the layer 3 protocols. At layer 4, we have a TCP, we have a UDP, right? These are the layer 4 protocols. Now, a firewall establishes a barrier between a trusted, secure internal network or the another network, which is internet. Means what it will do. See, your firewall is a perimeter device. Generally, this is the device who has a, at one side he has a connectivity with the internet service provider, and at the other side he has a connectivity with your LAN or your DMZ network or your inside network. Means see, because in your LAN area you only have a authorized users, your employees systems here, right? And all these systems, they are customized, they are basically designed as per your organization policies. Now, so guys, we have a full trust on your internal employees, right? Because they are not using unauthorized devices, right? They are not allowed to install any type of software because we have a policies on that system. So this particular area is known as trusted area because they are employees, they can trust on each other. But over the internet, we will not able to trust on anybody because in internet we have a good peoples and we have a hackers as well. And the intention of these hackers just to harm your services. So what firewall used to do, it will establish a barrier or it will establish one boundary, like in your home, right? We used to put one boundaries, right? It's a similar thing. So now let's try to understand two more terminologies. Ingress traffic and egress traffic. Now, guys, what is ingress traffic? See, now this ingress or egress, generally these two terms comes in terms of your interface or in terms of your port number. Interface or port. It is valid till that particular interface. So now, guys, whenever, let's take an example. See, from this PC, if I have sent any request towards this firewall, now, according to Ethernet 1x2 interface, because this traffic is going inside of that interface, so that traffic become the ingress traffic. Okay. Now, because this traffic is going out from Ethernet 1x1 interface, so that traffic is become the egress traffic according to this particular interface Ethernet 1x1. If I will get the reply, now this reply packet according to Ethernet 1x1 is the ingress, and according to Ethernet 1x2 is the egress traffic. So means the traffic which is coming inside of your interface is known as ingress traffic, and the traffic which is going out from your interface is known as egress traffic. Now this ingress, why I'm basically explaining this ingress, because when your firewall receives the packet on an interface, it will start processing that packet at ingress stage. And when this firewall complete the processing, now he has to forward this traffic out of the firewall, right? That particular stage is known as egress stage or the forwarding stage. So I hope everyone have a clear picture now on ingress and egress. Any questions with ingress and egress, guys? Okay. So one more time, I'm going with the definition. So guys, the device called so this particular device or this particular term called firewall. See, firewall is a device who will basically control the traffic on the basis of layer 3 and layer 4 information. Means it will check the source IP, source port, destination IP, destination port from the packets, and it will basically check that particular packets against the security policies, and it will take the decision he needs to allow the traffic or he needs to deny this traffic. And guys, always remember, if I will say the control means it will control on the basis of layer 3 and layer 4. If I will say the terms called inspection is known as layer 7, when it will basically start checking the layer 7. Now tell me one thing, in this TCP send request, is firewall do the check at layer 7? Is firewall perform any checks at layer 7 on SYN? Yes, Jamie, you are right. Ingress is the traffic which is coming in and on an interface, and the traffic, if traffic is going out from an interface, that is known as egress traffic. Why, guys, this TCP SYN? Why my firewall will not check any type of layer 7 data from TCP SYN? Because in TCP SYN we don't have any layer 7 information. Just remember, TCP SYN is not having any type of layer 7 information. Okay, just remember. Now, and guys, this particular device called firewall, it may be a hardware based device or it may be a virtual device. So maybe a hardware appliance or maybe a virtual appliance, and we will discuss all of them, don't worry. The main job of this firewall, what it will do, it will check each and every request which is going in or going out from this particular firewall against the configured security policies. If your traffic is good, means if your security policy, like we have a action in your security policy, if action says allow, then this particular traffic it will allow. If your action is say deny, then it will drop that particular traffic. Yes, Mathli, you are right. Incoming and outgoing traffic is dependent on the organization level. Yes, organization boundary. Or you can say the firewall boundary, the traffic which is going out from your firewall boundary, because you generally we have a firewall at perimeter. Perimeter means we used to put this firewall at the edge of your network. Okay. Now, now let's try to understand what type of firewalls we are having in the market. Okay. Then I'll move towards the stateful inspection. Now, so guys, in the market, generally we have a two type of firewall. The first type of firewall is known as next generation firewall. And the second type of firewall is known as legacy firewall. Now in your interviews, what you will get this question: can you explain what is next generation firewall, what is legacy firewall, or the next gen firewall versus legacy firewall? This is the most asked interview question as well. Okay, now let's try to understand. Now let's try to understand this next generation firewall and legacy firewall. Okay, so guys, first we will remember the list of next generation firewall. So in next generation firewall list, we have a very first firewall which is known as PaloAlto. The second next generation firewall is Fortinet or FortiGate. Third next generation firewall is Checkpoint. Then we have fourth next generation firewall which is Cisco FTD. Okay, so these are the main four next generation firewalls. Now we have a legacy firewall. So in legacy list, the very first firewall is Cisco ASA, most used firewall. Around 6 billion firewalls is still used for Cisco ASA. Okay, most stable device I have ever seen. The second legacy firewall is your Juniper SRX. Then we have a Cyber Roam. Then we have a Sophos. And apart from like we have a Cisco ASA, Juniper SRX, Cyber Roam, Sophos. Then we have a like we have other lots of other devices as well, like couple of firewalls from HP. Like we have a firewall from Dell as well, right? And you will get a long list here. Now, guys, see why these firewalls they are the next generation firewall and why they are the legacy firewall. Now let's try to understand the main difference. See, when your next generation firewall, what they can able to do, they can able to inspect the traffic on the basis of layer 3 information, like your source IP, destination IP, on the basis of layer 4 information, your source port, destination port, and at layer 3, or you can also consider here layer 3 protocol number. Okay, and also they can inspect your information at layer 7, because at layer 7 what we have a raw data, right? And these next generation firewall can able to read this particular layer 7 data against the malicious content. Okay, now these legacy firewall, they can only able to understand the layer 3 information and layer 4 information. Means by using this legacy firewall, we cannot able to control anything at layer 7. Means these legacy device, they cannot able to basically protect us from the malicious traffic. If there is a malware I have injected at layer 7, then your legacy device, they cannot able to protect from that malware. Okay, now, so guys, this is the main difference between legacy firewall and your next generation firewall. Your next generation firewall can process the traffic on the basis of layer 3, layer 4, and layer 7 information, and your legacy can only able to understand layer 3 and layer 4. Just remember, because your next generation firewall can able to understand the layer 7 information, so these particular devices, they can offer couple of extra features like app ID. App identification means in this next generation firewall, you can able to configure the security policies on the basis of application. Means, see, if you want to block or allow the traffic through this legacy devices for an application. Let's take an example, Facebook. How this legacy firewall can protect? You will basically create a access control list. In ACL, you will mention the IP address of Facebook and the port number of Facebook, right? And you will just mention action is deny. Now tell me one thing. Let's suppose in backend, this particular Facebook has added couple of more IPs, or maybe they have changed the port number in backend. Is your legacy firewall able to basically block the traffic? Is your legacy firewall able to control the traffic? No. And guys, if you will know the applications like torrent or the application called Yahoo Messenger, what they used to do, these particular applications, they are the evasive applications. What? They generally start running on some standard ports, and if that particular port is blocked by this particular legacy traffic, and let's suppose on that legacy traffic we have, let's take an example. Let's suppose torrent and Yahoo Messenger is working on 5050 port numbers. No, no. Now, in this particular legacy firewall, if we want to allow the internet access to our users, then we have to allow the traffic on 443 on port 80, and we have to allow the traffic for DNS, which is 53, right? Now, what they will do, now these particular applications, they will start sending the request into some well-known port numbers. And let's suppose they have sent the request port 80 and they have found that particular port is allowed. Now they will start running on that particular port 80. That is the evasive behavior because their port number is not fixed. And guys, torrent and Yahoo Messenger, their IP address and port number is not fixed. They are using the dynamically changeable IPs and port numbers. Means you cannot able to allow or deny the traffic for torrent through these legacy firewalls. But we can able to basically allow or control that the traffic on the basis on using this next generation firewall with the help of app ID feature. Guys, tell me one thing. Let's take an example on this particular server. You have hosted your website. Let's say your website is abc.com. And let's say that website you have built on PHP. PHP is the language which you are using. Now, let's take an example. See, let's suppose this particular server IP address is 151.7.100 and the port number is TCP 443. Tell me one thing. This IP address we can change easily. We can change the port number easily. But are you able to change this language or whatever the code on which your website is based on? No, it's difficult. It takes time, right? So what these next generation firewall able to do, because this particular code of program, whatever, when you will access this website, that program you will get as a layer 7 data. So guys, these firewall, they will check the layer 7 content and they will see like torrent has some specific pattern. Your Facebook have some specific pattern and your Yahoo Messenger have some specific patterns, right? So what these next generation firewall like PaloAlto, they will try to understand that pattern and they have a signature database for applications for, and according to that pattern they will read and they will match against that signature database. And what they will tell this particular traffic belongs to Facebook. And after that, whatever the rule we are having for Facebook, like we are allowing or we are denying, my fire will take the decision. Don't worry how app ID works. There's a lots of things I have to discuss and we have a dedicated class on that. Today I'm just giving you the basic overview. Okay, so this is the one more feature which is offered by the next generation firewall, which is app ID. Now apart from this app ID, we have a second most important feature in your next generation firewall, which is Antivirus protection. Now, let's take an example. Let's say we have this PC. This PC have a connectivity with the internet, and we have a one server here. And this is a malicious server. Now on this malicious server, what happens? Let's suppose this server is basically running the website using the PHP language. On this PHP board, I have added one malicious code. I have added one malicious code on this particular PHP server. Now when this particular PC try to download or try to access this server, that malicious code may come on this PC. So guys, when this particular code, or when he will access this particular server, this particular malicious code he will get as a as a layer 7 data, right? So guys, from this antivirus protection, you will not get with the legacy firewall, because they will not able to understand the layer 7. But your next generation firewall, they will understand the layer 7, and because they will inspect that layer 7. So what they will do, they will basically provide you the protection from the antivirus as well, if there is any malicious code is there. Okay. Now these next generation firewall, they have a one more feature called spyware protection. Means they will protect you from the spywares. If you are trying to access any website, right? On that website, if there is any malicious code is there, right, which act as a spyware, right? So it will protect you from these type of spywares. What is spyware? Spyware is a malicious program which used to run in your system, and it used to collect the necessary information, or it used to collect the confidential information from your PC, and it will upload that information into the hacker server. Now, we have a one more feature on these five, which is URL filtering. Means on these next generation 5, you can able to allow or deny the traffic based on the URL of an website, or based on the URI. Now this is your homework. You have to understand what is URL and what is URI. Search in Google, maybe after the session. Means what it used to do, we can able to allow the traffic on the basis of URLs and URI. Now, see, I have mentioned here the feature app IDs. See, each and every device has a limitation on applications. If I will say PaloAlto have a support for around 4.5K applications. Okay, but across the globe, we have a 3 million websites. So if you want to allow, deny the traffic for a website which is not application based, for that type of traffic, you have to allow either using URLs or either using URI. Means you can able to control the traffic on the basis of domain name. That is known as URL filtering. And see, when you will type a website like www.example.com in your browser, this example.com is a part of HTTP GET request, right? And HTTP GET is a layer 7. See, what is the, see, HTTP is a protocol at which layer? It's an application layer protocol. And at application layer, we have a data, which is layer 7, right? So because legacy firewall is not supporting layer 7, so they cannot able to do anything, but your next generation firewall will give you that particular protection, like which is URL filtering. Now one more very popular features, which is vulnerability protection. Let's suppose in your laptop you are running VLC media player. Let's suppose you are running this particular software called VLC media player, or let's suppose you are running One software which is Office, Microsoft Office Excel or Word. You are running Microsoft Word. And let's say that per Word have some type of vulnerability, or maybe this particular VLC media player have some type of vulnerabilities. Now what hacker used to do? Hacker try to exploit that vulnerabilities. Or maybe whatever the operating system, let's say you are running Windows. Let's say your Windows operating system have vulnerabilities. Or let's suppose on your Windows you are running some FTP service. Maybe that FTP service have some vulnerabilities, or maybe you are running SMB service. SMB service is having some type of vulnerabilities. So what hacker used to exploit these type of vulnerabilities to gain the unauthorized access of your system, because these are the weakness in your environment or in your laptop. If somebody is trying to exploit these vulnerabilities, and if we have a firewall in between, firewall protect us. So this legacy device, they cannot able to protect us. But your next generation firewall, because they can understand layer 7, so they will give you the protection. Okay, we have a dedicated classes on URL filtering vulnerabilities. I will exploit these vulnerabilities that time, right? That time you will get more idea. Now they have one more feature called Wildfire. Now this is the specific feature with regards to PaloAlto Wildfire Protection. So this particular Wildfire Protection, it will protect us from the real-time attacks. Let's take an example. There is a one community called Hacker 123. It's a community where multiple hackers are working, and now this hacker community, they have created one malicious code or one malware. It's a very new malware in the market. Even though these next generation firewall have not seen this malware yet, means if this particular malicious code they will throw towards your internal infrastructure, and when this particular malware seen by the firewall, because it's a new malware, and that these firewall, they don't have any type of signature for that. Now your antivirus, it will not able to catch that particular malware, or spyware will not able to catch, or the vulnerability protection will not able to catch. So what happens for this type of traffic? We have a wildfire feature which will protect us from the real-time attacks. What they will basically stop this particular malicious code at the perimeter level or at the firewall level, and they will do the sandboxing. They will upload that particular data into the Wildfire cloud for the sandboxing. Or Wildfire will give you the 0-day protection. Okay. Don't worry, we will discuss all of them in detail. Okay, here I'm just giving you the overview. Don't worry on that. Yes, Jamie, you are right. Wildfire is nothing. Raju, you can wait, man. You are asking like very like childish questions actually. Okay. Like wildfire is a policy or method, right? Wildfire is a feature in your firewall. It's a layer 7 feature. Okay. That we have to enable for the protection from the unknown malwares and all. Okay. Now, 7. We have a data protection feature. Here you will not get the full DLP solution, because we have a dedicated DLP solution, right? When we are discussing the endpoint securities. Okay, just remember. See, this data protection means it will protect you from, let's suppose, generally in your organization, we have a HR departments, right? These HR department, they have your personal information, personal data. They have your security, social security numbers, your PAN card numbers, your Aadhaar card numbers, your passport details and all, right? Or your bank details. If somebody is trying to upload that particular data, then this data protection feature will basically catch this type of traffic, and it will basically allow or deny. So these are the couple of layer 7 features which are only offered by the next generation firewalls, and they are not offered by the legacy firewall. And if somebody is asking these questions in the interview, you have to tell the first difference. Your next generation firewall can process the traffic on the layer 3, layer 4, and layer 7. You have to name out these 4 firewalls name there. In legacy list, you have to tell they will process the packet at layer 3 and layer 4, and you have to spell out couple of names of legacy firewalls. And because the next generation firewalls support layers and protection, so they will offer app id, antivirus protection, spyware protection, url filtering, vulnerability protection, wildfire protection, or data protection features. That's it. You don't need to go in that much depth. Okay. Now now guys, see, these legacy firewall can also act as a next generation firewall. How? If I will take an example of Cisco ASA, so in Cisco ASA, the main engine who will basically allow or deny the traffic on the basis of layer 3 and layer 4 information is known as a Lena engine. This is the actual code which is running inside your ASA firewall who do the packet processing at layer 3 and layer 4. And guys, Cisco will also have a one more device called IPS device. And these IPS devices, what they will do, this intrusion prevention system, they will protect you from the antivirus protection, anti-spyware protection, and vulnerability protection. Antivirus AV, anti-spyware AS, and vulnerability protection. So your IPS will provide you these 3 type of protections. So what we can do, on top of this Lena engine, we will add this IPS engine, and that IPS engine is known as SNOT. SNOT engine. Okay. Now, apart from that, let's take an example. Now, see, this antivirus, anti-spyware, and vulnerability we will get with the help of this IPS engine, right? So it's not, I can say, I can just mention here IPS. Now, if you want a URL filtering feature, then what you can add a, from the Cisco point of view, you can add a small part of WSA device or iron port device, which will basically perform the URL filtering. And they will basically, for doing this URL filtering, these devices, this Cisco ASA, they will basically do on the basis of Bright Cloud URL filtering solution. What is this Bright Cloud? Bright Cloud is a third party company who used to provide you the URL category related details. Now, if you want a protection like a wildfire type of protection or data filtering type of protection, you can add a AMP here, advanced malware protection AMP engine. And if you will combine all these engines, this device become the FTD, firepower threat detection, Cisco FTD. So this is a device from the Cisco next generation firewall. And because see, we have a Lena engine, then on top of we have a Snort, then we have a WSA, then we have a AMP. It's a very, very slow device. You will not get the good throughput here. And same thing is also known as UTM, Unified Threat Management. In UTM, what we will do, let's take an example. You just need a layer 3, layer 4 protection you will get from the firewall, and you need an antivirus, anti-spyware, vulnerability protection. So you can just enable the IPS on top of that. If you just want URL filtering, then enable the URL filtering or WSA code, which is also known as CX protection. Okay, so that's how these particular devices designed. But I am telling you guys, if you are using these UTM solutions on Cisco, it's very slow. Performance is very, very less. Just remember. Because see, we are adding one code on top of another one, means first this program will process your data, then this program will process the data. Okay. So guys, that's the major difference between your legacy devices and the next generation devices. I hope everyone is able to answer this thing if somebody is asking in the interview. Now let's try to understand the stateful inspection. Another most important question. So according to OSI model or the TCP/IP model, right? What we have a layer 7 information, then we have a layer 4 information, we have a layer 3 information, then we have a layer 2 and layer 1, right? So guys, what used to happen when my firewall receives any data? What it will check your layer 3 and layer 4 information within an IP packet and store that information in a table called session table of the firewall. All traffic flows through the firewall will be compared or inspected against the state table entries. It maintains the state of the connection when packet is traveling for the appliance. A stateful firewall maintains the state of a connection in the state table of the firewall. After adding information in state table, it forwards the packet to the destination. Now, guys, let's just try to understand the stateless behavior. And if you will know the stateless behavior, you can able to understand the stateful. So stateless firewall watch the network traffic and restrict or block the packet based on source IP, destination IP, source port, destination port, and layer 3 protocols. A stateless firewall do not maintain the state of the connection or the session. Extended access control list on Cisco routers is the best example for stateless device. Now let's try to understand that part first. Just give me 1 second. Let me just make some space here. Let me just clear this picture first. Guys, any lag on my voice? It is coming properly to everyone? Just confirm. It's coming right properly. Okay, great. Okay, guys. Now, see, guys, let me just tell you, your most of the firewalls like legacy or your next generation firewall, all are the stateful devices. Your Cisco routers, they are the stateless device. Now let's take an example of how stateless device do the data processing. Not firewall, here we have a router. And then we have a server. That server have IP address 151.7.100. Let's say this server is running on web on TCP port 80. And on this server, let's say we have a file of 2 GB. This is a .mp4 file, and this file, this PC wants to download. This PC is PC1 having IP address 10.1.1.100. This is the basic setup I am having right now. Okay, now again guys, let's back to the same story. Now when this PC, he will send the very first request towards this server. What is the detail we are having? The very first packet is your TCP send request, right? Now this TCP send request received by the router. Let's suppose router interface is F0 by 0 here, and we have F0 by 1. Now this router do the processing of this TCP send request, and he will forward this request over the server. Now, if I will write down the packet details, we have source IP 10.1.1.100, destination IP 151.7.100, source port 3050, and destination port is 80. Source IP, destination IP, source port, and destination port, right? This is the information we are having into the TCP send request. Now, see, when this particular router received this TCP send request, what it used to do? It used to start this TCP send processing. So I am just putting the major checks which is done by the router. So what it will do? It will process this request at the ingress stage. Means it will check we have received this packet on F0 by 0 interface. All the headers on that packet is properly formed or not, right? For any header errors, right? If there is, he has received the fragmented packet, then it will do the IP assembly, all such type of task, right? And after that, this particular router will also do the checks on the net. If we are using the net bucket as translation, this router will also check the access control list. If we have a ACL configured on that interface, right? This router will also check the routing table or the forwarding table, forwarding information base, to basically route the traffic. Apart from that, it will also check the CEF table if it's a Cisco router. So these are the couple of checks this router needs to perform. And once this particular first packet will go through with all these checks, now this router will forward this traffic towards the server. Now this server reply will come here. This is the second packet, which is TCP SYN plus EC. Now when this TCP SYN plus EC received by this router, now this particular TCP SYN packet, TCP SYN plus EC packet, the second packet will also go through with all these particular checks. So in case of Cisco router, they used to perform 27 checks. If you enable all the features, like you will enable policy based routing, IPSLA, so many things are there, right? Then it used to perform 27 checks. And see, this packet will go through with all these 27 checks and it will forward here. Now it will send the next packet. This is the acknowledgement packet, the third one, TCP-ACK. TCP-ACK will also go through with all these checks. It will forward the packet here. And once this particular thing is complete, now it will send the HTTP GET request. HTTP GET will also go through with all these checks. Now he will get the reply. This reply will also go through with this all these 27 checks in case of router. Now, guys, see, this particular device is not maintaining any type of state of the session. Each and every request and reply packet needs to go through with all these 27 checks in case of router. Now let's take in one basic example. Let's suppose Let's suppose this particular route, this to download this 2 GB of file from this PC, this router needs between this PC and this particular server. Let's suppose they have exchanged around 200 request packet, and let's suppose they have exchanged around 200 reply packet. So total of 400 packets they have exchanged with each other. And now let's suppose this particular router needs around 2 seconds to process one packet. Let's suppose it needs around 2 seconds to process the TCP SYN request. That needs around 2 seconds to process the TCP SYN plus ACK. Then 2 seconds to ACK. Then all the other packet also 2 seconds. Right? Now, out of these 27 checks, guys, the major checks, which is your net, access control list, and route tables, these are the main checks. And let's suppose these particular checks needs around 1 second with regards to each and every packet. Means, see, if they needed here to process this particular entire communication, in case of router, it needs to, they need to exchange all these 400 messages with each other with requests and replies, and they needs around 800 seconds. I'm taking these hypothetical numbers here for the processing this particular entire data. Let's take an example. Okay, now this is the case of router, guys. Now let's take an example of the firewall. Now we have a firewall here. Let's suppose we have a same PC1 here. We have a firewall here this time. And guys, I'm especially going with the PaloAlto firewall. And we have a same type of server here. This is my web server running on TCP port 80. IP address also same 151.7.100. And it is also having the same 2 GB of m.mp4 file. Means we are downloading some type of movies from that server. That PC is 10.1.1.100. This is Ethernet 1x2. This is Ethernet 1x1. This interface, the outside interface, or this particular interface is a part of outside zone. This interface is a part of inside zone. What is zone and everything we are going to discuss. Inside zone means it will basically have all the interfaces which connects your internal users. Outside means it has all the interfaces which connects your firewall with the internet. Okay, now, so guys, if you will see here the processing. 1 minute, what happening? Now guys, you can put your full attention here because this is most important part. Okay, see, now this PC will send the first packet. It's a TCP SYN packet. In this particular packet, we have a source IP, which is 10.1.1.100. We have a destination IP, 151.7.100. We have a source port, 3050, and we have destination port, 80. Very, very small diagram I'm having here. Now, when this particular firewall receive this TCP SYN request, it will start doing the processing. Now, guys, just remember, when this firewall receive this TCP SYN request, what it will do, it will start the TCP SYN request processing. And how it will do the processing, let's see. Now, I'm also discussing the some small amount of life of a packet inside your PaloAlto firewall, or how PaloAlto firewall do the packet processing or the packet flow in the PaloAlto firewall. So what, when firewall receive this particular TCP send request, it will basically put this particular process into the ingress stage. What are the checks it will do in the ingress stage? These we will discuss in some time, but here you have to just remember the very first thing which this firewall will do, it's known as ingress stage. The second task it will do with the flow lookup or the sessions table lookup. So guys, if I'll say the session table or the connection table or the flow table, all are similar. Do not confuse with that, like there is a different flow table, there are different thing like session table, connection table, flow table, all are same. Okay, don't worry on that. It will perform the flow lookup. Then next check, it will do the session setup state, or which is known as slow path. Session setup stage. Then fast path. And after that, forwarding stage, which is also known as egress stage. So this is how TCP send request is processed by my PaloAlto firewall. And I have not added here app ID and content ID. There are two more stages because your send request is not having any type of app or app related data or any type of layer 7 data. So app ID and content ID will bypass. Just remember now. And guys, here, just remember one more thing. The main checks, which is your zone protection, means protection from network attacks, your route table, your net table or your net lookup, your security policies, your DOS policies. These are the major checks in your firewall, and these checks is performed at slow path. Okay, now what this firewall used to do, see, when this firewall receive this packet, it will do the ingress stage processing, where it will extract your layer 2 information, layer 3 information, and layer 4 information from the packet. And it will basically start checking the header errors, all these tasks, right? So what it used to do generally, when this firewall receive the packet, it will needs to perform this flow lookup or session table lookup. So what it used to do, in session table, it has a source IP 10.1.1.100, destination IP, which is 151.7.100, source port 3050, destination port 80, and your layer 3 protocol number, guys, for TCP 6, and the source zone, which is inside. What it used to do, this firewall will collect this particular information, and this information we will get from this particular packet, right? We know the source, we know the destination, we know the port, we know the destination port and source port. We know this is a TCP traffic, so the layer 3 protocol number is 6. And we know we have received this packet on Ethernet 1x2, which is a part of inside interface, or which is a part of inside zone. So we have a source zone detail. This is the 6 tuple information. This information is known as 6 tuple information of your session table or flow table. What it will do, now this particular firewall will run the MD5 hash. On that information, it will basically generate one key, which is known as flow key. Or I can say flow key 1. Now on the basis of this flow key, it will basically check this particular session table, or it will do the lookup into the flow table. And this particular flow table they will maintain on the database called MongoDB database. Because to store the information, we need database, right? So it is using the MongoDB database. Now guys, why they are maintaining this flow table, or why it is doing the flow lookup? Let's try to understand. So because it's a very first packet, so it will not have any type of data here. So it will not found anything into the session table or the flow table, because it's just a very first packet. So what it will do, if I have not found anything on my session table, then I will go into the slow path. If there is a flow is there, then I will go with the fast path. I will bypass my slow path. But in our case, because it's a very first packet, there is no session, that will go into the slow path. Then in slow path, now my fire will go through with these checks. Now what it will do, it will go through with these checks. It will go through with the zone protection and DOS protection, route table, net, security policy, DOS policies, all of them. If your security policy is allowing the traffic, and if we have a proper route for that particular traffic, what it will do, now my firewall basically update the session detail into the session table according to this 6 tuple information, and your packet go into the fast path, then it will go into the forwarding stage. And once it will reach into the forwarding state, what will happen, your packet basically move forward here towards this particular web server. So this is the case of very first packet. Now we will get the reply from this web server. Now let me just denote the reply by using some different color altogether. This is the second packet, TCP SYN plus ACK. Now when this TCP SYN plus ACK received by this particular firewall, what will happen? Because this firewall have a session detail, right? Because when he received the TCP SYN request, that time it used to create two sessions. Client, it will create one session with two flows, client to server and server to client. And I will show you that part in some time. Just remember here, client to server and server to client. No. Now what happens basically? Now see, when this firewall receive this particular second packet, it will forward this packet into the ingress stage, then flow lookup. They will perform the lookup into the session table. This time they will found the details for this particular session. So they will bypass the slow path, and your data directly jump into the fast path and forwarding stage. So your stateful inspection, guys, this technology called stateful inspection, what it will do, with the help of this stateful inspection, or due to this technology or mechanism which is stateful inspection, each and every firewall, they maintain the state of the connection, and they will basically store that particular state of that connection into the table called a state table or the flow table. And for such type of packets, if there is a session is already there into the session table, they will bypass the slow path, and your major checks, your routing lookup, your net policy lookup, your security policy is a part of slow path. If your each and every packet will go through with this slow path, then this firewall needs some extra time for the packet processing. And guys, to bypass this particular, to accelerate this packet processing, this acceleration is achieved on the firewall devices with the help of stateful inspection mechanism. Okay, and what they used to do, if your device is a stateful device, it just maintain this state table where it will store the information of source IP, source port, destination IP, destination port, layer 3 protocol number, and the source zone detail. It will store all that particular detail into the session table. And now whatever subsequent request or reply, let's say this is the now third packet we have received, which is ACK. And after that they will exchange couple of HTTP get request and post request, right? Now whatever these request and reply packet, apart from first packet, means whatever subsequent request and reply packet received by this device, for all these packets it will bypass the slow path check. It will process them through the fast path only. And because the major check, let's take an example. If my firewall needs around 2 seconds to process the TCP SYN packet, and where around your slow path it took around 1 second, and let's suppose to download this 2 GB of file, they have again exchanged 400 total request and reply packets, then to basically complete that particular entire transactions they need around 401. They just needed 401 total second for the packet processing. In case of router, guys, what was the number? Number was 800 seconds. Because of this stateful inspection technology, how the number is and how the processing delay is basically reduced. Because we are bypassing these major checks, because these checks we can bypass. We don't need to send each and every packet through these checks, right? See, from when this PC will download this file from this server, IP address will remain same, port number will remain same, right? Your port number, your source IP, your destination IP, all that information remains same. Then what is the need of sending this packet through the slow path? So that is your stateful inspection. If you have not understood how that process is happening, don't worry. I have just explained for you here so you can at least understand when my firewall is receiving the packet, how it is doing the packet processing. Don't worry on that. Okay, because I will explain these things again in depth in your packet flow, maybe in tomorrow session. Okay, now guys. So with the help of this stateful inspection technology, each and every device, they will maintain the session table, or I can say state table, or I can say connection table, or I can say flow table. All are similar. On these flow tables, what they will store the source IP, source port, destination IP, destination port, layer 3 protocol number, and source zone details. These are the 6 tuple information of your PaloAlto firewall session table. If somebody is asking, can you just explain the 5 tuples of session table? So sometimes they used to say this 5 tuples because most of the people they come from the Cisco SA background in security. So 5 tuples means it will include source IP, source port, destination IP, destination port, and layer 3 protocol number. These are the 5 tuple information. Even the checkpoint, it just have a 5 tuple information. But only the device called PaloAlto to have a 6 tuple information because it just add the source zone extra here. Just remember. Raju, router will not maintain the session table because it's a stateless device. Just remember. Now, so as I have mentioned, stateless device, they don't maintain any type of session or connection detail into any of the tables like your Cisco routers. Okay, just remember, they don't maintain any session detail. Each and every packets they will send through each and every checks. Let's take in router, we have a 27 checks. Then each and every packet needs to go through with these checks. But in case of firewall, they will completely bypass the slow path, or they will completely bypass the session setup state. This stage is completely bypassed in case of firewall because of this flow table. Now let me just give you the basic idea of it. So what they used to do, they will check layer 3 and layer 4 information from the IP packet and store that information into this table called state table. All traffic flows through the firewall will be compared or inspected, means each and every packet, whatever PaloAlto firewall or any firewall receive, it will basically check that table against the state table. Means it will perform the flow table lookup. It maintains the state of the connection when packet is traveling for the appliance. A stateful firewall maintains the state of connection in the state table of the firewall. After adding information in state table, it will forwards the packet to the destination. And guys, now whatever subsequent request and reply packet we will receive in case of a stateful device, what it will do? It will bypass the slow path checks. Just remember. See, when it received the reply packet, it matched the packet information state table. If firewall received the reply packet, if the match packet is accepted, otherwise it will stop. Means it will generally allow that type of traffic. Just remember. Now, now guys. Now this technology called stateful inspection. A stateful inspection technology is basically developed by the person called Nirjuk. This is the person who has basically developed this particular technique called stateful inspection. And that time, that person, Nirjuk, he is a part of Checkpoint. He was a part of Checkpoint tech team. Before Checkpoint, he has worked with the NetScreen firewall. NetScreen nowadays is your Juniper networks. So he has worked with NetScreen, then he has moved to Checkpoint. During his Checkpoint journey in 1993, he has basically developed this particular technique called stateful inspection. And once this stateful inspection technology is developed, it has changed the inspection behavior of the firewall entirely. Means this particular behavior, this technology has changed the inspection behavior of the firewall, and now your firewall can able to process the packet in more efficient way and the more fast way. And guys, after 1994 onwards, all the other vendors like Cisco, we have a Cisco AC, that the most popular firewall, they have implemented the same technology on their devices. Now, the same person, he left the Checkpoint and he has basically come up with the new firewall, his own firewall in 2002. That firewall was is your PaloAlto firewall. But that time, this firewall will not done much business. During that time, this firewall is not done any much business, right? So what he has just again work hard. And in 2005, he has introduced he have just relaunched this PaloAlto firewall again. And that time PaloAlto is the first firewall who has come up with the app ID feature and the SP3 feature. Because of these two cool feature, this is the only firewall who is supporting during that time. So this firewall gained huge popularity in the market, and just within 3 years, in 2008, PaloAlto firewall become the number one firewall, and it start leading the firewall industry. And from 2008 till today, Palo Alto Firewall is the market leader in the firewall industry. Just remember. So the developer of your Palo Alto networks is the same person who has developed the stateful inspection, and the name is Nirjuk. He's a Israeli American. Okay, so we have seen the history as well. Or if you will check this link, if I will open, I'll go here. So you can see here, I think 2002 or 3 is missing here. So you can see they have launched this firewall in 2005. Then in 2008, it's become the number one firewall. And after that, so you can read all the things here, how they have launched the features and all, but you don't need to know this thing in a detail. And even though I'm not sure this is the correct information because this is the website, so whatever this information I have read from multiple websites, and this particular founder of this Palo Alto Networks is Nirjuk. Okay, just remember. Now guys, let's try to understand the Palo Alto Firewall product portfolio. Before that, let me just tell you one more information. See, when they have introduced this Palo Alto Firewall, this was the first firewall who is supporting the app ID feature, your user ID feature, and the content ID feature just in one box. What used to happen if you will use to purchase the Cisco solutions for the firewalls, you have to purchase Cisco ASA firewall, and ASA will protect you from layer 3 and layer 4. Then you have to purchase IPS device from the Cisco, and IPS will give you antivirus protection, anti-spyware protection, vulnerability protection. Then you have to purchase Cisco AMP for the malware protection. You have to purchase WSA for the URL filtering. So that time there was no firewall who is providing all these features just in same box. And Palo Alto is the first firewall who has introduced everything just within the same box. So that is the also another reason this firewall become very popular. And guys, according to the Gartner report, Palo Alto is the number one firewall. You can see here it is in the leader quadrant at the top. Then the second one is Fortinet. Then we have a Checkpoint, and after that we have a Cisco. And apart from that, we have a couple of other devices like ForcePoint, Huawei, Sophos, Juniper Networks, Barracuda, WatchGuard, Sonic Wall, right? We have lots of other other firewalls as well. So you can check these lists. And how basically this is decided? So guys, the name of your Palo Alto firewall is on the basis of one of the city in the California, San Francisco. We have a Palo Alto name city, right? And according to that city, that firewall name become like a Palo Alto. So Palo Alto Firewall is a USA multinational cybersecurity company, and they have a headquarters in California. So this is the headquarter of your Palo Alto Firewall. And Palo Alto Network was founded in 2005 by the Israeli American Nirjuk. Nirjuk is a former engineer from Checkpoint and NetScreen technology. NetScreen, which is Juniper. Palo Alto having world-class team right now. Right now, like they have a strong build-up, everything. And Palo Alto have lots of good features like app ID, URL filtering, content ID that time. Okay, so you can read out this detail and all because it's the same detail which I have already explained you. Now let me just give you the product portfolio first. Okay, so guys, in Palo Alto Firewall, they used to give you around majorly three types of solution. The very first solution, PaloAlto Network Security Solutions, means they have a cyber security related solution where they have a two type of box, PaloAlto Firewalls and the Panorama. Then they have a cloud security related solution which is Prisma Access and PaloAlto SD-WAN. And they have a one more endpoint related solution which is cloud based log solution, or it is like a log analysis solution. For that they have a Cortex data lake. So these are the main Cisco main PaloAlto product portfolio, guys. Here you can see we have a Prisma, which includes your Prisma Access and your SD-WAN. PaloAlto SD-WAN is also known as CloudGen X. And your cloud-based log solution is known as Cortex Data Lake. Okay. And for the cyber security, they have a PaloAlto Firewall and the Panorama. So this is the main product portfolio of your PaloAlto devices. And you can basically get the solution for the securing your enterprise with the help of firewalls. You can secure the cloud with the help of Prisma and Prisma ShaS. You can basically secure the futures, means how you can secure your logs. You can basically go with the Cortex Data Lake, Cortex XDR, and Cortex XSOAR. So these are the solutions which is offered by the PaloAlto Firewall right now. This is the product portfolio. Now, so Mohammed, if you want to know what is the difference between PaloAlto and Fortinet or Checkpoint, you can read it over the internet, because I'm not expert on Checkpoint and Fortinet. Okay, and I never do the comparison with the firewalls. All firewalls are good with regards to their features and all. Okay, now guys, let's try to understand the PaloAlto operating system first. So the name of your PaloAlto operating system is PanOS. The name of PaloAlto operating system is PanOS. Okay. Now this particular PanOS, how it has basically designed. So see, PanOS is the customized version of your BSD Linux. What they have done, they have basically there is a one Linux flavor with the which is named as BSD Linux. It's a open source flavor. It's a open source operating system. So they have taken this BSD Linux and they have basically done some customization on the operating system, this BSD Linux. They have done the customization, and after doing the customization means they have removed the services. They have added couple of services according to their requirement. Guys, tell me one thing. In your Linux devices, if you want to install any type of service, you have to install the packages, right? And these particular package runs as a daemon. Like if you will install the open SSH service on Linux, then that time SSHD daemon or that service start running on your Linux box. Now after doing this customization, they have basically added the pan application. Means they have added the PaloAlto application related code or the pan application package on your customized version of the BSD Linux operating system. And now whatever operating system they will get is known as PanOS. Means PanOS is a customized version of BSD Linux and the pan application. So the kernel of your PaloAlto operating system is the Linux environment. And that is the reason if you will run one command on the PaloAlto firewall, let me just go here. This is the CLI of one of my PaloAlto firewall. Come on. Sometime it's take time to come up. Yes, it's came. If you will run this command, so system software status, you will see inside your PaloAlto firewall there are multiple services are running these processes. It's the same thing. Let me just show you one more difference. Let me start my Kali Linux as well for a minute. Now, see, these are the demons I'm talking about. Because see, on this firewall, I can able to take the SSH because this daemon called SSHD is running this service. So the Palo Alto operating system is a part of BSD Linux. So means kernel is the Linux, and on top of that kernel, we have a PAN application, means Palo Alto operating system. Now, guys, if you have a little bit idea about the BSD any Linux, in Linux we have a user mode, right? And we have a root mode. We can say we have a root cell or root login, and we have a user login. So guys, when you will log in your Palo Alto firewall, we are logging into the user mode, which means we are logging as a PAN application level. This BSD Linux level we cannot able to log in because root access is restricted for the normal users. Only Palo Alto tech people who is from the layer 3 team or above, they can only able to log in into the root mode of the firewall. Root mode is disabled. Just remember, like in checkpoint, we can able to run this expert command, right? We checkpoint is allowed to log in as a root mode, as a root user, but this particular device is never allowed logging as a root user. Like in your Android phone, we are basically logging as a normal user. If you want to take the root access of your Android, you have to basically do the jailbreaking, right? You have to basically break the things and you have to become a root on that device. Then only you will get the high level privilege. Okay, it's the same thing. So I hope you will understood the why behind this PAN-OS, like what is the use of PAN-OS, like how this PAN-OS is built up. Now, the latest version of Palo Alto operating system is 11 series. PAN-OS 11. But guys, organization is using 10.2.5. This is the most stable version as of today. In industry, you will see this particular version in most of the boxes. There are a couple of new series boxes they have launched. Only on these new series box, they are basically comes up with the 11 series, but this 11 series is not stable. It has lots of bugs. Just remember, it's not a stable one. So this is the some information with regards to the operating system. Now let's try to understand the hardware series. So guys, Palo Alto Firewall offers two type of series. We have a Palo Alto hardware appliance or the physical devices, or we have a virtual appliance or the VM series devices. So majorly you can see there is a one more VM category now you will see, which is known as CN series firewalls. CN stand for cloud native series. Nowadays you have heard the name of Docker and Kubernetes. Docker and Kubernetes means you can run Palo Alto firewall as a Docker instance or as a Docker node in your Kubernetes. And for that you have to go with the CN series firewalls. And guys, this is the future. In virtualization, in future you will only able to see the CN series devices. Okay, just remember. So now in physical series, basically we have a 200 series box, we have a 800 series, then we have a 3200 series, we have a 5200 series, then we have a 7000 series, right? In Panorama we have a M200, then we have M500, 600, there is a M700 is also there, and M300 is also there from the Panorama. So these are the couple of hardware series from the Palo Alto networks. Now, let me just write down all the series properly here. I forget to clean this out actually. So from next class, I will do the cleaning in advance. So I have don't need to do it in front of you in these sessions. Okay. 1 minute. Okay, cool. So guys, the see Palo Alto series, this hardware appliance, they have divided into three categories. They have divided these series into three categories. The very first series is known as a for small organizations where we have a very less user count. In a small organization, we have a two series M2. We have a two series which is PA 200 box 200 series. In 200 we have a two series Palo Alto 220 and we have a Palo Alto 220R. This Palo Alto 220R we will use in the places where we have a humidity. Then they have also launched one more series which is PF 400. And this is the very latest series like Palo Alto 400 series. And after that, so for a small organization, either they can go with the 200 or either they can go with the 400. Still, both series are available, but in couple of times you will not able to see this 200 series because everyone will start using 400 series because it's a replacement one for 200 series. Apart from that, now they have a devices for medium sized organization. For medium sized organization, they have a very first series which is Palo Alto 800. In 800, they have a 820, 850. These are the devices they are having. Then they used to have, guys, this is the series which are available previously Palo Alto 200, but this is end of life and end of sale. They also have one more series, Palo Alto 300 series. This is also end of life and end of sale. To replace this Palo Alto 200 and Palo Alto 300, Palo Alto 2000 and 3000 series, they have launched, there is a one more series called Palo Alto 3200 series. They have a 30 to 20 box here, 30 to 50, and I think 30 to 60 is there and 30 to 80 is also there. We will check the data sheets for that. So now in most of the organization, guys, you will see 800 series or the 30 to 100 series most used devices in your HQ sites or in your branch offices. Okay. Now recently they have also introduced one more series which is Palo Alto 3400 series. So these are the series they have for the medium size organization and all are the hardware appliance, just remember. And then the third series they are having for data center or for the enterprise customers. And in these series we have a Palo Alto 5000 where we have a 5020, 5050. These are the 5000 series they are having, but this series also end of life and end of sale. So to basically to replace this 5000 series, they have introduced Palo Alto 5200 series, and this is the box you will see into most of the data centers. If you have a data center example, guys, anyone have Palo Alto in their infrastructure, you have checked your data center firewalls, you will be having Palo Alto 5200 series. I am 100% sure. They also have a one more series which is Palo Alto 7000 series. This is a very high-end box where you have a data in GBs. Then they have recently also introduced Palo Alto 5400 series and Palo Alto 7400 series. These are the new generation firewalls 5400, 7400, 3400 and 4000. I think, guys, there's a one more series they have introduced which is Palo Alto 1400 series. Okay, these are the series which is launched by the Palo Alto Fire with regards to the hardware appliance. Now But we can basically always check this particular details into the Palo Alto official website. So you can go here into that link. Before designing any solution, we will always check that particular details here. And here you can able to get all the Palo Alto box. So you can see we have a 5400 series, 5410, 5420, 5430, 5440, 5445, 3400, 3410 and all, right? And you can able to check the data sheets, right? What is the app ID throughput? It will have a throughput of 52 Gbps, means it can able to process the 52 Gbps traffic per second. Threat prevention throughput 35 Gbps, means if you will use app ID with threat prevention, then you will get 35 Gbps of throughput. Connection per second, it will support around 2,70,000 connection per seconds. Maximum session, it will support around 50 lakhs of maximum session, means it can able to support these many sessions. Then you can check the performance, session capacity. You can able to configure around 30,000 security rules, 256 security policy schedulers, then 6,000 net rule. Like you can always check these data sheets. You don't need to remember these numbers at all. Always we will check these data sheet when we are designing any solution. Just remember. Now we have a see we have a 7,000 series. So as I mentioned, your 3400 series or your 5400 series, these are the new box which is launched by the Palo Alto Firewall recently. Go here into the next page. See where 750, then we have a 54, then we have a 50 to 80, 50 to 60, 50 to 50, and 50 to 20. This is a 5200 series. 5200 series, I have seen like most of the data centers is using. But if now whatever the new replacement will happen for Palo Alto, now they will go with the 5400 series. Just remember. Then they have a 3200 series, like 30 to 60. Then we have a 30 to 50, 30 to 20. Then they have a 1400 series as well, right? Then they have a 850, 820. Then they have a 400 series. 400R is also there, right? For humid areas. So always check that data sheets, right? They have a 200 series, right? Guys, sorry about that. They don't have any series as of now for Palo Alto 7400. Okay, I was wrong here. So this was not there. So just remember they have a 5400 only. 74 maybe you will see in some days, or maybe by end of this year. Okay, now apart, these are the hardware appliance, and guys, you have to remember these series. Okay, it's not like you don't need to remember. You have to remember this particular series. In VM series box, what we have a VM series as well, right? And nowadays, guys, your VM series, we have a like VM50, VM100, VM2, V200, VM300, VM500, and VM700, right? These are the VM series devices is also offered by the Palo Alto Firewall. You can able to check the CPU, RAM, throughput, all of that detail. Okay. So these are the virtual box. Now, where we will use these VM series box, let's suppose you want to install Palo Alto Firewall on AWS cloud, or on Azure cloud, or on your Google cloud, or Oracle cloud, or Alibaba cloud, right? Or any other virtual environment like VMware virtual environment, or your Oracle virtual VMware environment. Everywhere when you will install, we will install these VM series devices only. And the third type of series is your cloud native series, CN series, or I can say container native series firewall. So CN series provides visibility and security to containerized applications, means let's suppose your application you are running over the Kubernetes clusters and all, right? And to secure these cluster, what we have to do, we have to basically go with these CN series boxes. Natively integrates into Kubernetes clusters, provide layer 7 visibility, application level segmentation, DNS security, and advanced threat threat protection security. Protects traffic across trusted zones in public data or public cloud or the data center environments. So Raju, always check the data sheet, how many users is can able to handle. Always we have to check the data sheets. We will not able to remember all of them. Okay, just remember. Always when you are designing any solution, ask what is the requirement from the user, from the customer, how many users they are having, and accordingly what we will do, we will decide which series box we have to basically pick. Okay, now guys, let's take a break for 5 minutes and we will back and we will basically start SP3 architecture. Okay, so guys, now let me just try to cover the stateful. Let me now just try to cover the SP3 architecture in your Palo Alto Firewall. Or is what is single pass software and parallel processing architecture in your Palo Alto Firewall. Okay, so now we are just discussing SP3. And guys, remember one thing, this question you will get definitely in the interview. Just remember, even though you are going for L2, L3, whatever the level, but you will get this question surely in Palo Alto. So just put your full attention now, guys. So where I have, let me just pick the things from here. Okay, now SP3 stand for single pass software and parallel processing hardware. Means SP3 is a combination of two things: single pass software, and the second thing is parallel processing hardware. Means SP3 is a combination of two things: single pass software and parallel processing hardware. And guys, this term called SP3, Palo Alto uses a lot when they will sell their product to the customers, because Palo Alto is the only device who has a this type of architecture. So now first, let's try to understand what is parallel processing hardware architecture. So to explain this part, guys, let me do one more thing, okay? Because I will take the help of two things here. So I don't need to go here and there. I can just refer the same diagram from two places. Let me just open here as well. It's taking some time, but it's okay. Yep, that's good now. Okay. So as I have told you, SP3 is a combination of two things: single pass software and parallel processing hardware. Now let's try to understand what do you mean by the parallel processing hardware. So in your Palo Alto Firewall hardware components is divided into two parts. We have a control plane and we have a management plane, and both of these planes is divided by the Palo Alto. This plane has their own CPU, RAM, hard disk, and your data plane will have own CPU, RAM, and hard disk. they are not sharing the hardware of each other. Just remember, means here we have a dedicated hardwares in management plane. So your control plane is also known as management plane. And your DP data plane is known as DP. And guys, this data plane now further divided into three another planes. Or I can say this data plane have three another chip. These are the dedicated hardware chip. Networking processor, security processor, and the content engine, or the signature match processor. So this content is also known as signature match processor or the pattern match processor. Do not confuse with that. Okay. Now, Palo Alto has divided its hardware into two parts: management plane and data plane. Now, guys, this management plane has his own jobs to do, own tasks to do, and your data plane will also have a own task to do. They are not dependent on each other. Just remember. Now, guys, tell me one thing. Whenever any user who is behind your Palo Alto firewall, let's suppose he has initiated the traffic towards Facebook. Now, this user's traffic is handled by the control plane or it will handle by the data plane. Just the normal basic question. Which plane will handle that particular user's traffic? So remember, your user's traffic is always handled by the data plane. When you will log in into your Palo Alto firewall and you want to do some type of configuration, that type of traffic is handled by the management plane. Means when you will take the SHS access or the HTTP access of your firewall and you perform the changes, these traffic is handled by the management plane. So now, if you will see here, Palo Alto architecture is divided into two parts. We have a control plane, which is also known as management plane, and we have a data plane. And then this data plane is further divided into three another planes: network processor and the dedicated hardware or chip which is used at this network processor is known as Liger chip. In high-end boxes, we have a Tiger chip, but in new generation boxes, that chip name is changed. But you don't need to know that much depth here. Okay. Then we have a security processor. This security processor is responsible for your packet processing according to the packet flow of your Palo Alto. And guys, this security processor, it has a chip called Octeon. So Octeon chip is responsible for doing the data plane related activities. And after that, we have a signature match processor. And signature match processor, here we have a dedicated chip which is known as Jaguar chip. And your signature match processor is responsible for two tasks: application identification and content identification. So guys, main layer 7 task is done by the signature match processor. Main layer 2 to layer 4 processing is done by the security processor. And we do have a network processor as well. So these are the three component of your data plane. Now, this particular management plane is responsible for the configuration management. Means when you will log in into your firewall and you will perform any type of configuration, these tasks done by the management plane. When you will log in, means if there is any type of log is generated by the Palo Alto firewall, so your configuration management, your log management, and your report management, means if you want to generate the reports, all these three tasks is done by the management plane of your firewall. And guys, your management plane has a dedicated CPU, dedicated RAM, and dedicated SSD. It also have a dedicated management interface and dedicated console interface. And apart from that, it also have a dedicated HA1 interface, which is high availability interface. So when we will discuss the high availability in your Palo Alto firewall, that time I will explain you what is the use of HA1 interface. Okay. So guys, now let's take an example. Let's suppose somebody has launched the DDoS attack in your data plane. Your data plane is under the DOS attack. Is this DOS attack impact your management plane? First of all, tell me what is the main purpose of this DOS attack? Main purpose of DOS attack is to consume your resources, consume the entire RAM, entire CPU, right? So, but because see, it's a dedicated plane, right? It has a dedicated resources. So if somebody launched the DDoS attack in your data plane, then all the resources which we have in data plane, they are just consumed. But your management plane is not, it will not impact. And if it will not impact, then we can log into the firewall and we can able to make the changes. And if somebody has launched the attack in your management plane, our data plane is safe, means your users traffic will not impact. Just remember, your users traffic will not impact. So this is the one more benefit you will get, guys. Okay, so as I mentioned, your data plane is divided into networking, security, and content. As I have mentioned, this content engine is responsible for the app ID and content ID, and this security processor will do the packet processing according to the life of a packet. Or this security processor is known as data plane CPU, DP CPU. And guys, this network processor is only process the packet which is offloaded by the DP CPU, means in all boxes, in all the PaloAlto hardware box, you will not found the network plane. This plane is not available into all the PaloAlto boxes. Just remember, in high-end boxes only, the high-end box which supports the session offloading, the high-end box which supports the session offloading, only they have the network processor. A network processor can able to process the packet on the basis of layer 3 and layer 4, means it can able to do the routing related task, it can able to do the net related task, all of them. Just remember, does the software share by the, say I have not discussed anything with the software as of now, banker, just wait to complete all of them. Okay, now, and guys, if you have noticed here, these three planes, they have a dedicated resources because these are the independent hardware chip. They have a dedicated CPU and dedicated RAM. They are also not sharing the resources with each other, means they can able to process the packet independently. That's why it is known as parallel processing hardware, means your management plane can work and also your data plane work, means these two planes is working parallelly. Even inside your data plane, we have a three another planes: network processor, security processor, or content engine. All these particular engines or processors, they will also work independently. That is known as parallel processing hardware, because they don't have any type of resource level dependency on each other. They have a dedicated resources and dedicated tasks to do. Maybe when we receive a packet, let's say we have a receive a three packets, like packet number 1, packet number 2, and packet number 3. Maybe this packet number 1 is processing is going on at networking engine. Maybe packet number 2 processing is going on at security engine, and maybe packet number 3 processing is going on at content engine. And all these particular three packets, my firewall is processing at the same time in parallel way. So that is why the architecture or the hardware architecture of your PaloAlto firewall is known as a parallel processing hardware. I hope you understood the how or why PaloAlto firewall able to do the packet processing in parallel way, because of this type of architecture, which is parallel processing hardware architecture. Now, remember one thing, most important part. Let's suppose Let's suppose there is some issue in your data plane. Maybe there is a one process which is running in your data plane, and that process is not working properly. Maybe some type of bug is there into the process. Guys, tell me one thing. When you have a laptop, right? When your laptop used to hang, what you used to do? If your laptop is hanged, what you will do to solve the problem? Reboot, right? We will reboot the things. So what? When you will reboot your laptop, then entire laptop will shut down, right? So in similar way, if there is any problem at network procedure or at security procedure or at content procedure, we can reboot these particular data planes. We don't need to reboot the entire Palo Alto box. If there is any problem at management plane, we can able to reboot the management plane processes. Like if you will, I can see these are the different process I'm running for different tasks. Let's suppose I'm not able to take the SSH access of my firewall properly. Then I can just restart the SSHD service. If there is any problem with the, let's suppose routing, then I will basically restart the route the process. See guys, majority of these processes is running in your management plane. So your management plane will also used for the, apart from the logging, configuration and reporting, it will also manage your daemons or the processes. Let's suppose there is some issue with the with your interface, then we will reboot this if mgr daemon. If there is any problem with the bpn ipsec bpn, I will basically check the logs of ikmgr daemon, right? If there is any problem with the with your captive portal, right, I will restart my l3 sbc service. And all these services are part of management plane. And guys, if you have noticed in other boxes, we have to reboot the entire firewall if there is any issue with the processes. You will not get that type of flexibility here. So this is also one more benefit you will get because of its architecture, because of the Palo Alto Firewall architecture, right? If I will run this command show session info, if you will check, we have a DP0. So guys, right now, if you will see this particular picture here we just, you can able to see only one processor, right? But in high-end boxes like Palo Alto 5200 series, we have a 3 security processor. Now assume the throughput, and we have a 2 Jaguar chip, and all these chips, they will work parallelly and they will do the packet processing. Okay, so your actual sp3 is applicable with the high-end boxes like 5200 series or 5000 series or your 5400 series box or your 7000 series box, because low-end box like 800 series or 200 series, you will not found any type of networking processor. They don't have any content processor. They just have a security processor or they just have a Octeon chip. And this is the only chip who will do all the tasks. Just remember it. Now, how the data path looks like, let me just draw one diagram so you can able to understand the things. Don't worry guys, see if they have mentioned in security procedure, it will do app ID, user ID, URL match, policy match. No, it's wrong. It's all wrong. It is just a theoretical stuff. Okay, the actual app ID or content ID related task done by the Jaguar chip here. Let me just draw one of the diagrams so you will understand the things properly, how the architecture looks like in actual. So in actual, basically what we have, generally we have all these interfaces here. So let's suppose these many interface I'm having. And apart from, see, these are my copper ports, then I do have a couple of, let's say, fiber ports as well. Let's say I have 4 fiber ports here. Let's say this is my Ethernet 1 by 1. Then this is Ethernet 1 by 8. Then we have even my 2, 3, 4 as well, like 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8. Then here we have a 1 by 9, 1 by 10, Ethernet 1 by 11, Ethernet 1 by 12. Let's say I have a 12 port on my firewall. And these are my copper ports. And these are my SFP plus ports or the fiber port. SFP plus ports. So what happens, guys? Now this particular network module, this particular thing is known as network module. I'm not sure how many have, basically you have added the extra network modules on the firewall or maybe on the router or switches. These are the network modules. Okay. So we used to get a network module with 4 interfaces, 8 interfaces, 24 interfaces like that, or 16 interfaces. Okay. So now this network module will have a connectivity with one more chip here. That chip is known as Marvel chip. So means all the data which we receive into these particular data ports, we will basically receive, they will basically deliver this data towards this Marvel chip. All the copper ports and all the fiber ports, basically they will deliver that data to one more chip called Petra. These are the hardware chip we are having, or this is how the hardware looks like. Now this Marvel and Petra chip, they have a further connectivity with one more chip, and this chip is known as network processor. Either you have a Tiger chip in high-end boxes, or in low-end boxes you have a Liger chip. These are the name of the chips, and it's just a FPGA, field programmable gateway array. These are the some electronic engineers terms. Okay. Now this Marvel chip will have a connectivity with this particular processor like this, and these are the high speed fiber links, and these links is known as joy links inside your PaloAlto firewall. Okay, these are the high speed links. And after that, guys, what we have after that, we have a one more chip which is known as data plane CPU. This is the main chip basically inside your PaloAlto firewall, which is DP CPU. And this chip is your Octeon chip. And this chip will also have a connectivity like this through the joy links. These are the high speed fiber links. And this is known as data plane CPU. And now this chip will have a further connectivity with one more chip is known as Jaguar chip. And they have a connectivity like this. Now, this Jaguar chip will responsible for doing the task which is app ID and content ID. These tasks is done by the Jaguar chip. Now in this Jaguar chip, we have a two type of algorithm. We have a DFA and AHO. DFA is responsible for app ID and AHO is responsible for content ID. Now this AHO is also replaced by the PScan. This particular algorithm is replaced by the PScan. So now these are the two algorithms which is running on this Jaguar chip, and they will do your all the app ID and content ID related tasks. Content ID related task, which means your URL filtering, your antivirus protection, your anti-spyware protection, your vulnerability protection, your data filtering, your wildfire protection. All these tasks is done by the Jaguar chip. Just remember. And according to your packet flow, your ingress stays. your flow lookup, your session setup stays, your fast path, and your forwarding, all these tasks done by the data plane CPU. All these same tasks, whatever perform the DP CPU, this network processor can also able to do, but it will only do the packet processing for the packet which is offloaded by this data plane CPU to network processor. Means this data plane CPU will tell this network processor, these are the session you need to handle. You don't need to forward these sessions to me for the processing. So means the offloaded session is handled by this particular processor. And generally, what type of session they will offload? Let's take an example. Let's suppose we are receiving the encrypted traffic via HTTPS. Now tell me one thing. We have received the HTTPS traffic here, and we are not using SSL decryption. On the firewall SSL decryption, we are not using. Now, see, SSL decryption is not, we are not using, then we will send this encrypted traffic here as well in the Jaguar chip. Is Jaguar chip able to do anything because we are receiving the encrypted traffic? It is not able to read the data, right? It is not able to understand what we have at layer 7. If it is not able to understand anything for this particular session, it is the best idea to forward each and every packet towards the Jaguar chip. You can tell me, guys, it is the best idea? No, we don't need to send these type of packet. So what it will do, this Jaguar chip will send one message to Octeon chip. It will mention layer 7 is completed, and when this particular flag it will add. Now these type of sessions it will offload to Tiger or Liger chip or this network processor, because he can tell this particular session you can only process, because you can able to also do the net related task, security processing related task, and the routing related task. And generally the first packet is always handled by this chip only. After receiving couple of packets, only it will basically offload, and after offloading, this particular chip generally do the net translation and your layer 2 forwarding and layer 3 forwarding, means ARP lookup, all these tasks. Okay, I will not going into too much depth, otherwise you got confused because it's just a first lecture. Okay, so this is how the data path of your Palo Alto Firewall looks like. This is how the hardware component inside your Palo Alto Firewall is connected with each other. This is the data path. Okay, Arshad, actually I don't have a habit to repeat the topics. Ask your doubts during the Q&A. Just visit the recording and you can ask your doubts tomorrow as well. Okay, because the same part, this part I will also cover again in your tomorrow class when I will discuss the packet flow. If I will repeat each and every packet, then we cannot able to complete that syllabus as well. Okay, now I hope, guys, this architecture which is like parallel processing hardware is understood to everyone. And let me just show you here. As I have told you, this network processor is we will use as a offloading processor. It's just a FPGA. It's a ASIC type of chip. Okay, provides custom hardware support, that is offloading for the initial packet parsing and flow lookup and direct forwarding for certain packet, certain payload packets that do not need layers of inspection. Means we can offload the packets which don't need the layers of inspection, like your ping related traffic. Such type of traffic we can offload easily. Remember it. Then we have security processor. This is also known as data plane processor, and we have a KLVM chip, because in latest version they have changed the chip name, but like you can say like Octeon chip in the interview, they will basically understand. Okay, because this is something for the tech engineers only. Handles most of the data plane processing of the firewall. Means most means almost everything. All the packet processing is handled by this process only. For firewall that do not have a network processor, the security processor handle all the packet processing. And guys, you will not found this network processor on each and every box. It is available some high-end boxes only, just remember. Then we have a hardware offload. Or what? We see, we can also network processor, it's just a offloader. And guys, see, inside your PaloAlto 5, apart from these components, what it is also having one more thing. Let me just show you that part. Okay, I think that is not here in this diagram. I have to look for another diagram. Let me just go here. Just give me 1 second, please. Let me just show you one more diagram, guys. Just give me 1 second, okay? There's a very good diagram I was having. Okay, if you will see in this diagram, recording is started. Okay, yes. So if you will see in this diagram, see, all these particular processor, they have a dedicated RAM, dedicated CPU as well for doing their task. Okay, just remember it. And all your data interfaces, they have a connectivity with the network processor. If in some boxes you don't have a network processor, then all these network modules, they have a direct connectivity with the security processor. I'll show you these diagrams as well. So that's how the signature match processor looks like in your PaloAlto firewall. And let me just see what I have apart from that. Mhm. Okay. Now, guys, let's try to understand this diagram. This is the architecture diagram of PaloAlto 5000 series box. I hope this diagram is visible to everyone properly, guys. Hello. Just confirm writing yes in the chat. Okay.
Yes, it is visible.
Okay. 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 Now, if you will see in this diagram, as I was mentioning, we have a interface fabric, and these interfaces generally they have a connectivity with the Petra chip, which is a switch fabric. Okay. Now, this particular Petra chip, it has a direct connectivity with the network processor, and where we have a Tiger chip. And after that, this Tiger chip has a connectivity with the security processor. This is your security processor, and here we have a Octeon chip. And now in this particular security processor in 5000 series box, we have a three security processors. We have a three Octeon chip, DP0, DP1, and DP2. Now why I'm basically explaining these data planes, because when you will do the troubleshooting and when you will run the advanced debug commands on the PaloAlto firewall, some of the logs you will found in data plane 0, some logs you will found in data plane 1, and some logs you will found on data plane 2. Now you need to aggregate all these logs, and after that only you have to do the processing. You have to start analyzing them. And guys, your actual SP3 is applicable on these high-end boxes because they have a three data plane CPUs. And guys, as I have mentioned, almost all the packet processing is done by the data plane CPU only. So maybe if we have received 3 or 4 packets, for the packet was maybe first packet getting processed here, second packet getting processed here, or maybe third packet getting processed here. Means all these packet is getting the processing at the same time. That is also known as parallel processing hardware, guys. Then we have a Jaguar chip, and we have a two Jaguar chip, and you can see lots of RAMs here. Why we have a lots of RAM? There is a reason. Because in Jaguar chip, it is having a lots of signature database. It has a signature database for antivirus, for anti-spyware, for vulnerability protection, for data filtering, for file. It has all these type of data, all type of signature database for app ID database and all, right. And it used to match that particular data against these particular processors. One more thing, guys, inside your data plane CPU, here in Octeon chip, we do have dedicated decompression chip, IPsec chip, and the SSL chip. So all your SSL related tasks is done by the SSL chip, IPsec related tasks done by the IPsec chip, and all your decompression related tasks is done by the decompression chip. Means your SSL decryption, it is done by the SSL. All your IPsec related tasks done by this particular chip. They have a dedicated hardware component for doing these complex tasks as well. And if you will see here, we have a dedicated management plane where we have a dedicated RAM, SSD, and the CPU core. So that's how the Palo Alto Firewall architecture looks like. Now let me just show you one more thing. And after that, I just move forward towards the single pass software, because single pass software is very easy if you will understand the parallel processing hardware. So for that, I have to search for one more diagram. Where is that one? Yeah, this is the one. Even though you don't need to know these much information, but if you have a info of these things, it's very good. You can able to explain the same thing in your interviews, right? Now, if I will open this particular diagram of 800 series firewall, and 800 series firewall, they have these many details. In 800 series firewall, what they have, they just have one single chip. They just have one single chip, which is known as Octeon chip, which is also a data plane CPU. Now, they have a RAM, dedicated RAM. They have a dedicated decompression engines, IPsec SSL chip, right? And they have a DCPU where they have a data plane. They have a dedicated management plane. They have a dedicated SSD on management plane, and the USB port, management port, and the console port. Now, all your interfaces, like which is RJ45 ports, SFP ports on PA820 box, they have a connected with the Octeon chip directly. Now you may ask, we just have a Octeon chip, then who will do the task with regards to app ID and with regards to the content ID? So guys, what happens, as I have mentioned, we have an algorithm called DFA and AHO. These algorithms runs into the Octeon chip, and they have a segregation at the software level, not at the hardware level. They have a segregation at the software level, and they will run these DFA and AHO algorithm, and these two algorithms will do the app ID and content ID related tasks. Just remember, in high end boxes, in low end boxes where we just have a Octeon chip. Okay. Now, if you will see, this is the architecture of your Palo Alto 5000 series, and we have already seen this architecture, right? This architecture looks like completely in this way. And how these component is connected, they have a connectivity like this. Marvel chip and Petra chip, it has a connect with the Tiger chip, which is network processor. Then we have a data plane 0, data plane 1, and data plane 2. And after that, we have signature match processor 1 and 2. And they have a connect with the joy links of 10 Gbps. Okay, so that's how. And also they have a management plane. That management plane is also connected with all these planes via virtual link, because The main actual brain of your firewall is here on the management plane, right? That's how the connectivity is, guys, with regards to your devices. I will not explain too much today, but it's like that only. Now guys, let's try to understand the single pass software. So let me just tell you one thing. I just remembered this thing. Your single pass software is applicable at content engine or at your content ID, which is Jaguar chip. In Jaguar chip, you have seen it has a lots of RAM, right? So what used to happen? See, when we used to receive a packet, so from that packet, your not like that. I have to connect both. So what used to happen from that particular packet, this chip called Octium chip or your data plane, it will extract the layers of information and it will basically forward that layers of information to your Jaguar chip. And this is your Jaguar chip. In Jaguar chip, it has a RAM. So in RAM, generally we have a memory locations. So what used to happen, that layers of information is stored at these memory locations. And now in this content engine, because it has a signature database for your antivirus, for your anti-spyware, right? For your vulnerabilities, URL filtering database, right? URL DB. It has a like your wildfire database, wildfire signatures, right? It has your database for data protection and all, right? Now it has these signature database. So what happens when this particular packet is stored here, all these particular database, they will load that packet together just in single one go. They will load that packet in one go and they will basically do the inspection. They will check antivirus code, will check for the virus related stuff. Anti-spyware will check for the spyware related things. Vulnerability will check for the vulnerabilities. URL filtering DB will check for the malicious URLs. Wildfire will check for the malwares, right? Data filtering will check for the data filtering related things, right? And what they will do, they will check and they will basically reply just in one go. And your result will pass to the Octeon chip. And now it's a decision which is taken by the Octeon chip. He has to block or he has to allow the traffic. If there is any type of anomaly is detected, means if we have received some type of malicious traffic and for that traffic we are denying or we are blocking that thing, then they will that message pass to the Octeon chip and Octeon chip change the state of the sessions right away from active to discard, and all the packet which is coming through that particular session now discarded by the firewall. So that's how your single pass software architecture works. In single pass architecture, all this processing is happening just in one go. Now let me just go through with one more architecture of your legacy devices. Then maybe you will get the whole idea how legacy firewall is doing the packet processing. Let me just make it little bit small here. This is the multi-pass architecture. Now guys, in multi-pass architecture, if you will remember the old architecture of your Cisco solution portfolio, generally what we used to have for layer 3 to layer 4 protection, they used to have a Cisco ASA firewall. For antivirus, anti-spyware and vulnerability, they used to have a IPS device. It's a dedicated hardware box. Then for URL filtering and for proxy, they are having the WSA box iron port, right? For this particular DLP solution and all, they have a AMP solution, right? Now, these are the dedicated box. Now let's suppose we have one user here, and that user is sending some traffic. Sending some traffic towards here. Now his traffic first go to ASA. ASA will do the processing. Now it will take some time in the processing. Then this packet is went to the another device, which is IPS. Now IPS will do the processing, then it will forward to iron port. It will do the processing, then it will forward to AMP. Then AMP will do the processing, then it will reach to this particular end server. So because this packet is flowing through multiple devices, means this packet getting processed multiple times. And if it will get processed multiple times, what will happen? It will add some delay. It will add some processing delay, right? Now, so this was the old architecture we will be having. According to new architecture, if I will write down the architecture of FTD, Cisco Firepower Threat Defense, Cisco Firepower Threat Defense, what will happen? We have a Lena engine, right? Which is your ASA. Now on top of Lena, they have added the Snort engine. Then on top of this Snort engine, they have added the WSA for URL filtering. And on top of that, they have added the AMP. That's how they have designed his code. So what will happen if we have received the packet here? So first your packet is processed by the Lena, which is ASA. Then ASA will forward this packet to Snort. Snort process it and will send back this packet to Lena. Then Lena again now forward this packet to WSA. Now WSA send the result here back to Lena. Then Lena again forward this packet for AMP processing, and AMP again send back to this packet Lena, and then packet go out. Like in this particular diagram, we have received the packet. Packet get the processing by the Cisco ASA, like a Lena code. Then this packet is now packet is moved further, and it is processed by the URL filtering, sent back, came to Lena. Then it is moving further. Then again it is going for the IPS, which is not. Then it is going for the AV. Means if you will see here, these particular processing is repeating every time. Means packet is coming back and going for the next processing. This is a multi-pass architecture. Means packet needs to move here and there multiple times. But in PaloAlto Fire, what happening? This particular URL engine, IPS or AV engine, all of them just doing the processing just in one go, right? We will load into the Jaguar chip, got processed, go back, done. That is known as the single pass software, guys. I hope you understood what is the single pass software now. Because this is this is till that extent only I can able to explain, and I hope you will get the points now. Okay. Okay, let me just see here. Now guys, your packet flow I will start tomorrow because I need another 2 hours to complete this packet flow and the initial access. So these are the topic which I will discuss in your tomorrow class.